the positive from the output is given to the positive of the PN junction diode. So you can see here positive of the output is connected to the positive of the PN junction diode. The negative of the PN junction diode is connected to the positive of the ammeter. So the negative of the PN junction diode is connected to the positive of the ammeter. The negative of the ammeter is connected to the negative of the DC output. So the negative of the ammeter is connected to the negative of the DC output. The positive of the voltmeter is connected to the positive of the DC output. So the positive of the voltmeter is connected to the positive of the DC output. The negative of the voltmeter is connected to the negative of the DC output. If you are selecting the input voltage as 1.5 volt, you have to place it in the upward position and you have to take the reading along this scale, which is 0, 0.25, 0.5, 0.75, 1, 1.25 and 1.5. Similarly, here if we are taking the reading in milliampere, you have to shift this knob to the top position and then you have to look into the graduated scale of 0, 2, 4, 6, 8 and 10. Switch on the apparatus. Now you have to find out for the forward bias. So this knob has to be adjusted. So you can see here, as this knob is turned, there is a deflection in the voltmeter and in the milliammeter. Here you can see the least count for the voltmeter is 0.025 volt. That means the first division has to be taken as 0.025 volt, and for the milliammeter it is 0.2 milliampere. Turning the knob for the forward bias and adjusting the voltage, you can see here for 0 it is 0. For the first division, that is for the first reading, for the voltmeter it is 0 and for the milliammeter it is 0. Now we shift and slightly turn the knob, adjust the voltage. Now you can see here the voltmeter is in the fourth division. So fourth division means now it is 0.1 volt and the corresponding reading in the milliammeter is still 0. Now the voltmeter reading is 2 and the corresponding reading in the milliammeter is still 0. Now it is 0.3 in the voltmeter and in the milliammeter it is still 0. Now in the voltmeter it is 0.4 and in the milliammeter it is still 0. Now in the voltmeter it is 0.5 and in the milliammeter it is 0.2. Now in the voltmeter it is 0.6 and in the milliammeter it is 0.6. Now in the voltmeter it is 0.7 and in the milliammeter it is 1.4. In the same manner, check the readings by increasing the forward bias volt and check out the readings for the voltmeter and check the corresponding milliammeter reading. Note down the readings till you go to the last scale of the voltmeter and the milliammeter. For the observation and calculation, we could see that the least count of the voltmeter was 0.025 volt, least count of the ammeter was 0.2 milliampere. In the forward bias, when the volt was 0, the forward bias current in milliampere was also 0. For a voltage of 0.1, the forward bias current is 0. Forward bias voltage, when it was 0.2, it is again 0. For a forward bias voltage 0.3, the forward bias current in milliampere is 0. Forward bias voltage 0.4, the forward bias current in milliampere is 0. Now you can see a sudden increase in the current for the voltage, and this voltage is called as the knee voltage. So for